Every year around this time, the entire tech world starts circling the same date on its calendar. It happens like clockwork, the moment Apple gets ready to pull the curtain back on its newest lineup of flagship phones. And this year, that moment is nearly here again. Multiple supply chain insiders and longtime Apple reporters, the kind who have accurately called these launches years in a row, all seem to be converging on the same window for the big reveal. Based on the patterns Apple has followed for the past several years combined with fresh component and manufacturing leaks, the event looks set for September 9th. If Apple sticks to its usual rhythm, pre-orders should open within days of the keynote, which means the very first units could be landing in customers' hands as early as September 18th. This isn't just internet chatter or wishful thinking from fans refreshing rumor blogs. According to multiple supply chain sources, trial production has already begun on Apple's main assembly lines. Trial production, sometimes called test production, is a genuinely significant milestone in the life of a new phone. It's the stage where real factories start building real, physical validation units, not simulations, not CAD renders, not internal prototypes locked away in a lab, but actual hardware coming off actual assembly lines. Engineers use these units to catch flaws before mass manufacturing ramps up. Things like connector alignment issues, thermal problems, or assembly errors that only show up once you're building the device at scale. The moment trial production starts is effectively the moment the hardware design gets frozen. Nothing changes from here except paint and packaging. What was once a spec sheet and a rendering is now a phone sitting on a bench somewhere in a factory in Asia, being poked, prodded, and stress-tested. While the release date is generating plenty of buzz on its own, the real headline this year belongs to the camera. Leakers are pointing to a feature that has genuinely never appeared on an iPhone before: a physical variable aperture on the primary rear lens. To understand why this matters, it helps to know how iPhone cameras have worked up until now. On every iPhone to date, the aperture, the opening that lets light into the lens, has been completely fixed. It never changes size. Instead, the phone leans entirely on computational photography, using algorithms to fake background blur and to manage exposure digitally. A variable aperture flips that on its head by introducing actual moving mechanical blades inside the lens assembly, the same basic principle used in professional cameras and, more recently, in a handful of Android flagships experimenting with the same idea. These blades physically expand or contract depending on the lighting around you. Step into a dim room or shoot at night, and the blades open wide to pull in as much available light as possible. Walk outside into harsh, direct sunlight, and the blades narrow down to control exposure and prevent blown-out highlights. Because this adjustment happens mechanically rather than through software trickery, you get a more natural-looking background blur and cleaner exposure control without the phone having to guess and reconstruct the image afterward. It's the difference between a camera that captures light correctly the first time versus one that captures it wrong and then tries to fix it in post-processing. To pull off something this mechanically complex, Apple reportedly needed a custom sensor built specifically for the job. According to leaks, Sony has developed a new sensor for this purpose, reportedly labeled the IMX905, engineered to talk directly to the mechanical aperture system in real time. Paired together, the sensor and the moving aperture are said to deliver noticeably better low-light performance, sharper detail retention around edges, and quicker autofocus response. The kind of gains that usually only come from swapping in entirely new hardware rather than tweaking existing components. None of this camera hardware would mean much without a chip powerful enough to drive it. And that's where the next big leak comes in. Component leaks point toward a new processor, expected to be called the A20 Pro, built using a next-generation manufacturing process from TSMC. This new packaging approach allows significantly more transistors to be packed into the same physical space. In practical terms, for anyone actually using the phone, that translates to noticeably faster performance alongside less heat buildup during demanding tasks. Recording high-resolution video, running graphically intense games, or processing on-device AI tasks should all draw less power from the battery than before, which matters just as much for battery life as it does for raw speed. Flip the phone around to look at the front, and there's a visual change that should be obvious the moment you pick it up. The dynamic island, the pill-shaped cutout at the top of the screen, is reportedly shrinking noticeably. Ever since Apple first introduced this cutout, A common piece of feedback has been that people want it smaller, since it eats into usable screen space. Apple is apparently solving this by redesigning how Face ID physically works. In earlier iPhone generations, the flood illuminator, one of the components responsible for facial recognition, sat directly inside that visible cutout next to the front camera. On this new model, that illuminator is reportedly being relocated underneath the display panel itself, hidden beneath the actual pixels. Because it no longer needs to poke through a visible hole in the glass, the cutout at the top can shrink. You keep the same secure, fast facial recognition you're used to, but you get more usable screen real estate for video, browsing, and everyday use. Battery life is another area getting a serious upgrade this